Welcome back to the deep dive. Today, we are getting into source material we've put together under the title Silicon Skies, the Orbital Race for AI Sovereignty.
Right.
And if you've been tracking tech trends, you know that the demand for computation is it's exploding. But this deep dive isn't just about, faster chips.
No.
It's about where those chips are going to live. We're talking about the new space race, a competition not for flags or moon rocks, but for fundamental infrastructure.
We're talking data centers, servers,
Yeah,
floating GPUs, as the source of material calls them.
exactly. Floating GPUs that power all of modern AI.
And our mission today is really to cut through the noise. We want to give you a clear look at this. This huge shift. We're focusing on three things.
Okay.
First, the surprising environmental reason that's actually forcing AI off planet. Second, who's actually winning this race right now. And third, what this whole idea of AI sovereignty really means for, the tech you use every single day.
Yeah. The first thing you think of when you read this stuff is just the cost. The logistics must be a nightmare. Launching anything into orbit is fantastically expensive.
The most expensive thing we do, yeah.
So that brings up the immediate question. Why? Why would anyone go to all that trouble, all that expense to move these massively overheating servers into space? I mean, can't we just build data centers in the Arctic? Or even underwater? Why orbit?
And that's really where you have to start, because the why here is so counterintuitive. It's not a vanity project. What's so fascinating is that the real urgency, it's all rooted in thermodynamics.
Okay.
And just unsustainable resource use right here on Earth. The material frames this orbital shift not just as some cool tech feat, but as an environmental necessity.
Let's unpack that, because that completely flips the script, right? We're all conditioned to think of space launches as, environmentally destructive.
Sure they are.
But you're saying the impact of staying on Earth is actually getting worse than the cost of launching. What is the specific problem that AI is causing that's so bad it warrants this extreme solution?
The problem at its core is cooling. And the resource that fuels that cooling is water.
Water.
When we talk about training the next generation of large language models, the LLMs, we're talking about a kind of computational intensity that generates just extraordinary amounts of heat.
So the chips are running hotter and longer than ever before, densely packed.
Exactly. And to stop those chips from basically melting, you need cooling on an industrial scale. The sources are really clear on this. Data centers are now consuming millions of gallons of water.
Millions.
Millions of gallons every single day, just for cooling. AI is now in direct competition with farming, with cities, for fresh water, often in places that are already water-stressed.
Wow. When you put it like that, it's not a tech problem anymore. It's a global resource crisis. We always talk about the energy AI uses, but the water part of it, that feels like a hidden critical factor.
It's the Achilles heel of scaling AI on Earth. And that's why this wild idea of moving it all to orbit starts to look, well, almost sensible, economically and environmentally.
Okay, but let's play devil's advocate for a second. Launching rockets burns a huge amount of fuel, puts tons of carbon into the atmosphere. How do the sources justify that? Aren't we just trading one crisis for another?
That's a crucial point, and they address it by looking at the life cycle. The launch is a big one-time pollution event. There's no denying that.
Right.
But on Earth, a data center is a continuous feedback loop of consumption. It generates heat, so it needs to run massive electric pumps and HVAC systems, which consume energy and water day in and day out for decades.
And in space?
In space, you use physics. The cooling mechanism isn't water, it's radiative cooling into a vacuum.
So you just radiate the heat away.
You radiate it into the perfect cold sink of deep space, you move the server to orbit, and the heat management problem, it basically disappears. You need way less power and zero water. So that one-time launch cost eliminates a continuous massive operational cost on Earth.
So floating GPUs isn't about being closer to the stars. It's about finding the world's best, most efficient refrigerator.
And removing that water constraint entirely.
Yes.
It completely reframes the competition. It's now a race for resource independence.
Which is why the sources call it a race for sovereignty. It's about controlling a resource that now defines the global economy.
Absolutely.
So that brings us right to the competitive landscape. If the environmental why is that urgent, we have to ask who is winning the how, who's actually deploying this stuff. We hear a lot about U.S. companies, but the material we have suggests the real lead is elsewhere.
Yeah, if you look at what is deployed, stable, and actually operational today, the lead belongs to China. And it's not even that close.
Really?
While U.S. innovation gets the headlines, China has been relentlessly focused on deployment and long-term stability.
So what have they actually done? What's in orbit?
They've already deployed a fully functional 12-satellite computing constellation.
Yeah.
You can think of it as a small distributed data center that's already flying hundreds of miles over our heads. It's not a pilot program. It's working infrastructure.
Okay, but anyone can get something into orbit. What's the metric that makes this so significant? What proves its true superiority?
The metric that matters is resilience, uptime. They have maintained that hardware stable and functional in orbit for, get this, 1,000 days.
1,000 days.
1,000 days. That's the key detail. It proves they've solved the really hard engineering problems. Stable power, correcting for orbital decay, radiation shielding, and maintaining a high bandwidth link to Earth, all while doing heavy computation.
1,000 days isn't a trial run. That's residency. They've established a working system outside of anyone's direct terrestrial control.
Precisely. It gives them a sustained, undeniable early lead in establishing real computational sovereignty.
Okay, so while China's focused on stability and just getting a constellation up and running, the U.S. private sector, specifically Starcloud with NVIDIA, has gone a different route. They're focused on sheer power.
Correct. The U.S. approach has been to push the absolute limits of what's possible. The huge achievement here was successfully putting an NVIDIA H100 chip on a satellite.
And the H100, for anyone listening, is the gold standard. It's the chip behind basically every major AI model right now.
Yeah.
And it's famous for generating a ton of heat, which makes this an incredibly bold move.
It's the ultimate test of that orbital cooling idea we were just talking about. And they proved it works. Not just by surviving, but by doing something really complex. They trained Andrej Karpathy's nano-GPT model while in orbit.
They trained an LLM in space. That's a foundational moment.
It is. The sources call it the first AI born in orbit. It proved the whole pipeline works, end to end, away from Earth. Data in, processing, training, results out. That's autonomy.
Let's just pause on the scale of this leap in power. If China established reliability, what did this Starcloud platform establish?
The comparison is pretty startling. This one system has 100 times the computational power of anything that has ever been sent to space before.
100 times.
That's the metric that matters. It signals the leap from using space for, simple data relay to using it for heavy-duty, current-generation AI workloads. The kind of stuff that would rival a small data center on the ground.
It's the moment orbital computing became powerful enough for the most demanding tasks of our time. So we've got China focusing on wide, stable, long-term infrastructure.
And U.S. private industry focusing on these monumental bursts of processing power. It sets up a fascinating dynamic, resilience versus raw speed.
It really does. And that sets the stage perfectly for what comes next. We have the why, the environmental driver, and the competitive how. So let's bring this down to Earth. How does a 100x power boost 300 miles up affect the AI that you and I use every day?
The sources have a pretty clear projection on this. By 2030, which is coming up really fast,
It is.
the processing core for the most advanced AI services might literally be coming from the stars.
Yeah.
Think about the really demanding stuff like complex language generation or real-time
But
simulations.
why space? Is it just the cooling, or is there a speed advantage too?
It's a combination, but the latency benefit is huge. Fiber optic cables on Earth are limited by the speed of light through glass, by all these terrestrial bottlenecks. Orbital platforms can talk directly, line of sight, to ground stations anywhere. That architecture, plus the raw power from perfect cooling, means the fastest response for a global AI query will likely get routed through these orbital clusters.
So my request to, Siri or ChatGPT, instead of going to a data center in Virginia, might get beamed up to a chip orbiting right over my head.
And you'd get a faster, better answer. It's a complete reimagining of cloud architecture.
But this is where it gets complicated. This brings us back to that term we keep using, AI sovereignty. Now that we have the tech framework, let's define that. What is it exactly?
In this context, AI sovereignty means a nation, or even a corporation, can control the fundamental engine of its economy and defense, and ensure that engine is immune to outside pressure, immune to terrestrial problems or legal jurisdiction.
Because it exists in a legal vacuum. It's not in any country's airspace.
Exactly. That's the core tension. We're solving a very real environmental crisis, but in doing so, we're creating this totally new category of governance risk. The tech is just outpacing the law.
Right. That phrase you mentioned from the source material.
Yeah, that when you hear that consumer AI will be beamed from space, it's either the coolest thing I've ever heard or a total sci-fi nightmare.
It highlights that perfectly because you're creating these powerful systems that could operate beyond any real human accountability.
And what this deep dive really shows is that this race is moving at orbital velocity. It is not a future vision.
No, it's happening.
We already have stable operational constellations thanks to China's 1,000-day achievement. And we have massive computational breakthroughs, like that first AI born in orbit with 100 times the power.
So the shift is happening now. The resource pressure on Earth pretty much guarantees it's irreversible.
We're literally watching the birth of an entirely new computational layer for the planet.
The race for AI sovereignty is officially on. And the finish line, as the sources say, is at the edge of the atmosphere. And the tech is moving faster than our ability to really understand the implications, which leaves us with a final thought for you. If the most powerful, most critical AI systems are designed to exist and operate entirely beyond Earth's jurisdiction, what happens when a critical decision, economic, logistical, maybe even military, is made by an intelligence that can't be subpoenaed, can't be regulated, and can't be shut down by any power on Earth? We solved the water problem, but we may have just created the era of unaccountable intelligence. Think about that the next time you connect to the cloud. We'll see you on the next deep dive.